Okay, so yeah, this is the Zoom meeting for February 18th, Math 1401. And yes, the question on the table is section 5.2, the general addition rule. Okay, and basically, do I need to, we wrote down a formula like this. It was for probability of A or B. This word or means add, which is where the addition rule comes from. And it means for you to take the first, we call that the first probability of the first, add the probability of the second, minus the probability of both together. Now, I made an explanation at the Monday 12 p.m. Zoom meeting. Do you want to see my explanation of where this formula comes from, or do you believe it?
Yes, please.
Well, what happens is, this is both occur together. They draw circles of this. First circle A, second circle B. The circle represents the probability of A, is represented by that entire circle. All right. Probability that B happens is represented by this circle. These are called Venn diagrams. Where they overlap, this is referred to as A and B. And basically, A, B occur together. Now, there will be formulas, in fact, two formulas for this and, but they occur in 5.3 and 5.4. They're going to give you situations in 5.2 where you're supposed to be able to puzzle this and out without a formula. So you see what happens if you take all of A, you get this overlapping area. And then if you take all of B, you get the same overlapping area. So it's been counted twice. It's overcounted, in other words. And that's why you subtract one of them out. And so what happens is through the homework, they give you situations and they want you to puzzle this probability out using this formula. Do you need an example?
Yes, please.
Well, okay. Should we just do a simple one with numbers? Like page 250, this is 5.2, page 251, say problem 15. Find probability E or F if E, now this word and isn't your math and like up here, E and F are what they call mutually exclusive. Under this situation, they cannot occur together. E and F cannot occur. Oh, C, I meant that to be a C. You occur together. So the circles are like this. Here's E, here's F, which means the probability of E and F is 0. When they use this phrase, the other word for it is disjoint. So what happens is I write this out. The probability of E or F is the probability of E, add the probability of F. I always write down all three pieces minus the probability of both, and F, E and F. And since they use this word mutually exclusive, that last piece is 0. Now, where they give you these numbers in the problem, I'll show you. Probability of E is in the paragraph, right? The actual problem is 15 up here. but they tell you the probability of E is 0.25 right here, and F is 0.45. So this is equal to 0.25, add 0.45, and minus 0. I think you'll find that's 0.7. 5 5 is 10, carries a 1, yeah, 0.7. Did that help?
Yes, it does.
Okay. Do you need another example of this kind of formula?
Yes, please.
Well, we could go down to 25. They give you a table. I'm doing problems I haven't done in the other videos. And this is basically crime statistics. This is for 2013 murder cases. And this was the weapon used in the murder. And this was the probability that the weapon was used. So basically in the actual cases, you can tell, you know, what's the most common kind of weapon used. You can tell it's a handgun in a murder, 47% chance, or 47% of murders were done with a handgun. Makes sense. You can hide the handgun in your pants or pocket or whatever, pull out, shoot someone and put it back. Ooh, me? Not me. Whereas, you know, how many times you see someone walking down the road with a rifle or shotgun or something, you know? It's pretty obvious, pretty long. Not many used, not many murders or use a rifle or shotgun in comparison to a handgun. All right, so there's the data. The questions are on the next page. Do we need to show you how to verify that this is a probability model? Or A, this is page 252. Verify that this a probability model. Do we need to show you how to do that, or is that obvious?
Yes, please.
Well, you show that it obeys the two rules. That obeys the two rules. Hope you know the two rules. Rule 1 is that all the probabilities had to lie between 0 and 1. All right, well, without a lot of ado, you can tell these are decimals between 0 and 1. Just by observation.
Okay.
That's all you got to check. Nothing negative, nothing bigger than 1. Yes. All right, number 2, they must add to 1. If they don't add to 1, there's another murder category or weapon. There's some other weapon that they've used that they haven't accounted for if they do not add to 1. So it takes a little bit of punching time. Do y'all want to punch it yourselves, or you want to take your Zoom time to watch me punch this and see if they add to 1?
I think you should punch it.
Okay, let's see if they do. I'll write the numbers down. Do 0.472, add 0.023, add 0.025, 0.170, add 0.122, add 56, add 0.132. Does that equal 1? Let's find out. The suspense is killing me. Let's see. 0.472, I'll clear the whole thing. Okay, so 0.472, 0.023, 0.025, 0.17, 0.122, 0.056, 0.132. Anybody want to give us a drum roll? I'd like a little drama. If y'all can hear my drum roll. Ah, yes. Always like a little drama. It is valid, or this is a probability model. This is what you always do. They give you a bunch of problems, especially through 5.1. They have you verify things. And you always check that it obeys these two rules. A probability model. Do you want to see the other parts?
Yes, please.
B, they want the probability a rifle or shotgun was used. A rifle or shotgun. Okay, see, this is like your A, this is like your B. So this would be equal to the first one, the probability of a rifle, plus the second one, minus probability someone used a rifle and a shotgun. You see how it sets up?
Yes, please.
Okay, this is how every OR is set up. I always write down all three pieces. All right, now when I look at this, we said these things could not occur together. Now this is where you can kind of overthink things. Things get fuzzy. Is it possible in a murder that someone could pick up a rifle and shoot somebody and then pick up a shotgun, you know, and go, yeah, that guy's not dead enough. I'm going to use a shotgun too. Pick it up and shoot the guy again with a shotgun. Is that possible?
Nah.
No.
Okay, I didn't ask if it was likely. I just asked if it was possible.
At the same time, I don't think so.
You guys ever watch the Godfather movies? You ever watch Game of Thrones? Now, they don't use shotguns and rifles in Game of Thrones because it's a fantasy thing that, you know, before we use swords and hangings and everything. You'll find all kinds of creative ways to kill people in Game of Thrones. I've never seen a full episode all the way through. I've seen clips on YouTube. But yeah, if you ever watch the Godfather movies, Godfather 1, Godfather 2, you know, they came out in 72, 73. They're pretty old, but they're regarded as two of the finest movies ever made. Find all kinds of creative ways to kill people. So yeah, this would be a really creative way of killing someone, but it would be possible. Now, the thing is, did they give us a category for it? Is there a category for rifle and shotgun? See, this is just rifles. This is just shotguns. So is there another category that has rifle and a shotgun used? Do you see one?
No.
No.
So do you understand that? That means we are going to have to assume this is 0.
Mm-hmm.
But it's an assumption. Because it is possible to use a rifle and a shotgun. If you really want somebody dead, it's possible to use both. Okay. Now, do you see where to get these probabilities of a rifle and a shotgun, or plus a shotgun here? The rifle, 0.023.
Mm-hmm.
The shotgun, 0.025. So this would be equal to 0.023, just add 0.025. I think you'll find it's tough to add stuff horizontally and line up the places. That looks like 0.048. But you can always punch it. 0.023, add 0.025. Yep. 4.8% chance someone used a rifle or a shotgun. You want to see more parts?
Yes, please.
Okay, well, if you look at part C, I'll go to another page. This is 25C. Still on page 252. All right, they do an OR with three things. This would be the probability, and they really mean handgun or rifle or shotgun. Sometimes they don't word these things really that well. Handgun, rifle, or shot. They only have one or in the thing, but they really mean this. All right. So this really means probability that they used a handgun plus the probability of a rifle plus the probability of a shotgun minus, once again, all three used. Handgun and rifle and shotgun. And once again, is it possible to use all three things?
No.
Well, it actually is possible. Is it likely? No, probably not. But yeah, I mean, it's possible. You pull up your handgun, bam! Oh man, he isn't dead enough. Let's use a rifle. Bam! No, he isn't dead enough. Let's use a shotgun. Bam! Okay, but probably not likely.
Yeah.
Okay. And they didn't give us a category for it. They would have had to given us a category of murders that used all three. Okay, and so where do I get the numbers for these? Once again, off the table. 0.472. Rifle, 0.023. Shotgun, 0.025. All right. Tough to do things horizontally with decimals. Usually like to line up the places vertically, so I just use a calculator. 0.472, 0.023, add 0.025. Looks like 52% chance someone used one of the three, one or the other or the other. 0.52. There was another part. Okay, do you want part D?
I think it's the same thing, except it's different. Is it different?
It is slightly different.
Okay.
Weapon other than a firearm. Probability weapon other than firearm, which means gun, some type of gun. Well, looking at the table, you just got to pick out the categories that this would apply to. All right, weapon other than a firearm. So see, a handgun's a firearm, rifle, so wouldn't use a rifle, unknown firearm. Okay, so you see, we can't even use the first four in these, right? They're all some type of firearm.
Okay.
All right, so it starts with knives. So really, if we write it out in words, you'd have the probability of knives. Someone stabs somebody. Then somebody used hands and fists. This is really a violent example. The only one, you know, they really should be a little more. See, I don't know what other is. I guess other means anything other than this. So we probably should include other. Kind of implies they're using something else other than anything listed up above. Trying to think what could that be? Nunchucks, baseball bats. Think of what else, other things you could use. All right, well, knives is 0.122. Hands and fists is 0.056. And other is 0.132. .31, yeah, that's what the book has. So yeah, other means other than a firearm. Questions about that?
No, please.
Okay. Well, if you want to just finish it, part E are murders with shotgun. Unusual. Did you watch Monday's video? We covered what the book has a number for an unusual probability. Did you happen to watch that and see, or do I need to tell it again?
I do, but I have to rewatch it again before
Okay.
I can really understand.
When they use the word unusual, they mean a probability less than 0.05. I use less than or equal to, because it gets a little fuzzy if it's 0.05. I call it less than or equal to. I think the book strictly uses less than, but I use both. So what I do, looking at the probability of a shotgun, yeah, shotgun is 0.025. That is less than, so probability that someone used a shotgun equals 0.025. Yes, that is less than or equal to 0.05. Yes, unusual. So yeah, if you got called out to a murder scene, you were a detective or you're the crime lab or whatever, they keep very close track of what is used in crimes and everything. That's their full-time business. They found someone, a body, and it's got shotgun wounds, and it clearly was murdered with a shotgun. They would consider that unusual.
So only a shotgun.
Lost my camera. Can y'all still hear me? Can y'all hear me? No one's talking. Okay, can you hear me now?
Yes, please.
Okay, I came back. Yeah, the internet, I'm sorry. I don't know why it kicks out on occasion, but it kicked out. Let me get the camera back. Let's see. Okay, we're back. Did someone have a question? We've been at this about 30 minutes now. We started about 8:15. What else can we cover? Or is it late enough at night? Y'all are
Maybe on Monday.
maybe a what?
I said maybe on Monday. For now, I'm good.
Okay. Okay. Yeah, we'll be back on Monday. I'm going to send around. I'm going to be out of town all weekend, and I'll be back either Sunday night or Monday morning. So I'm going to have to delay the Zoom on Monday till like 9 p.m. Monday after my son's Boy Scout meeting. But I'll send around a note with the link for that.
Okay.
Okay.
Okay. Does anyone want to hang around and talk to me about your tests or anything? I have to do, if I talk about your tests with you, I have to do it privately. So I could send you a link. Let's see, I got somebody on the chat. Oh, yes. Okay. Okay. I've got one person who does. Anybody else?
Yes, but August can go.
Okay, well, the thing is, I can't do it in this format where everybody can listen.
Yeah.
So what I can do is write your names down and I'll just set up a schedule on the Zoom and send you an individual link. Now, I don't know how long Mr. Augustine's going to want to go. Can you hang around until, I don't know, like, I don't know, maybe 10 minutes, 10 minutes after him? Or do you want to email me for a separate time we can set up?
For me, I'm good. You know, we had a chat in the earlier class, so most of my problems were resolved by you. So if you want me to leave, I can leave, so you can have like a private chat with Naomi.
Okay. Well, I don't really want you to leave. I don't, yeah. But you don't need me to send you a separate link for a separate session?
No, sir. It's just if yes, please, if you can, please. I will appreciate that. Yes.
Do you want to do that tonight?
Yes, sir.
Okay. Get that off camera. Anybody else want a link for a separate session?
Yes, please. But definitely not tonight.
Okay. Do you want to send me an email when you can do it?
Yes, please. Yes.
All right. And Ms. DeRosa, you want to send me another email when you can do it?
Yes, please.
No.
Oh,
For now,
sorry.
it's fine.
Okay. You don't need a session?
I'm sorry?
Mr. Rose, you don't need a session?
Oh no, it's fine. I'll just do the tests by
Okay.
tomorrow or Saturday.
Okay. Well, there's no rush. Take
Okay,
your
sure.
time and make sure you do it when you're ready, because you only get one submission.
Oh sure, thank you.
Okay, sure thing. Well, all right then. Can we end this session?
Mhm.
And I'll send
Yes,
out.
please.
Okay, well, sure thing. And
Thank you so much.
okay, well, sure thing.
Thank you.
Apologize for being late.
Sure.
Oh, that's fine.
Okay. All right, Mr. Augustine, I'll send you another link. All right.
Okay, sir.
Sure thing. Do it in just a minute.